All right, so today we're going to talk about adding and subtracting unlike fractions. So one of the things that you guys told me when we first started talking about adding and subtracting fractions is that the denominators have to be the same. So whenever you see the word unlike fractions, that means that the denominators are not the same. So that is going to be our first goal, our first priority, is finding that common denominator, okay? A common denominator. And there are an infinite amount of common denominators. Okay, what does infinite mean? Never ending. There's a never ending amount of common denominators that we could come up with. Okay, so infinite amount. But typically, we choose one in particular, and that would be called the least common denominator, right? We'll abbreviate denominator, or the LCD. There's actually another name for the LCD. Do you know what that is? The LCM. So what does LCM stand for? Least common multiple. Now, when you're finding the LCD or the LCM, a lot of you are really doing it completely mentally, okay? You're doing it in your head. You're pretty good at it. But since this is the beginning of the school year and you've had, some time off, I want to review how to find that least common multiple. Because some people still struggle a little bit with doing that. And I want you to have a strategy for what you can do if you're just having a hard time doing it mentally, okay? So, do you know what multiples are? All right, so how about I can maybe help you out? Like if I said, Daphne, can you tell me the multiples of 9? All right, 9, 18, all of us help us out. 9, 18. Now, I could keep going forever, right? So I'm gonna stop at 63. So that kind of goes into this whole infinite amount thing. I mean, we could list multiples until our hand fell off. But we don't want to do that, all right? We need to stop at some point. So if I gave you another number, like 15, and I wanted you to find the LCM of 9 and 15, then, all right, we've listed the multiples of 9. So now if we list the multiples of 15, which would be... Now, would there be any reason for me to go on past 45? No. There would be absolutely no reason to go past 45 because when I get to the 45, I'm kind of thinking and kind of looking up here at my other list, and I'm thinking, I'm looking for a number that's up there. I'm looking for a number that's up there. And as soon as I find one, I want to stop. I don't want to do any more work than what I have to do. I don't know about you all, but that should always be the thing. To work smart, not hard. Have you heard that before? Yeah. So that would be working smart. Now, another way to work smart would be if you were just given, I know I gave it to you in a way that we had to do the 9 first, but if I gave you the 9 and the 15, I don't know about you, but I pretty much know the multiples of 9 pretty well, all the way up until, 99 or so, and then it gets a little fuzzy. But, okay. But I'm just saying, I would probably start with the bigger number. I'd probably start with the 15. And if I did 15, 30, I know 15 is not a multiple of 9. I know 30 is not a multiple of 9, but I know 45 is. So that would have saved me tons of time. Okay? But again, I do not, when I'm saying to show your work, I do not expect any of you to have to show this. Okay? There's another way. Oh, the prime factorization thing. Yes. You do like that? Okay, so I like doing prime factorization, but I don't know. I feel kind of like this about doing prime factorization to find LCM or the GCF, so you can do both, right? And the only reason that I feel that way is because I was never taught that way in school, so I never got comfortable with it. But if that's the way that you were taught and you like it, then do it. Like, by all means, do it. It's a great way, you know? It's just, yeah, that can happen, right? So prime factorization, it makes it a little bit more foolproof. No silly mistakes. Okay, so I think that we have reviewed how to find the least common multiple, which we're going to use for that least common denominator. Another trick that you can use to find just a common denominator, let's say if we had a problem that one denominator was a 9 and one denominator was a 15, what is another strategy that you can use that would just give you a common denominator? Just multiply the two denominators together, right? So if you multiply the two denominators together, you're going to get a common denominator. It's just not always going to be the least common denominator. And that's not a big deal. You're just going to have to simplify more, okay? Which, again, is also not a big deal, all right? But if you aren't allowed to use calculators, then, like, doing 9 times 15, I know you can do that without a calculator, but it's going to take more time, right? So if you can do this in your head, then you're going to have smaller numbers to work with, which will make it easier for you to solve. Okay, so that's my spiel on that. Let's write down the steps then for these problems. Steps, we're going to find a common denominator. So notice I am not saying that you have to find the least common denominator. That's not a requirement. You just need to find a common denominator. Once you have found a common denominator and you're changing the denominator to something, what is the second thing you need to do then? What about our numerator? Right, so if you change the denominator, you have to change the numerator, right? You have to change the numerator. Do not forget that. So if you change the denominator, you have to change the numerator. And I'm sure you've heard what you do to the bottom, you got to do the top, right? Whatever you do to the bottom, you have to do the top. And once you've done those two steps, then it goes right back to what we were doing yesterday. So then you're just going to add or subtract like normal. That'll be our last step. So we'd add or subtract the numerators, we'd keep our denominator, and then we would simplify, just like we did yesterday, that you guys did a great job on. So we're going to do a few sample problems, and then I'll let you get started on your assignment, okay? Because again, I know that this is all review, but it's something that you don't work with fractions every single day. It's just something that you do need to review. All right, everybody have that so I can move on, you think? No? Oh, well, I can do like this. The page extender helps with that. So, all right, so let's just start with fractions, and we'll do a couple fraction ones, and then we'll do mixed numbers, because the mixed numbers are going to be the more challenging ones. Let's do 1/2 plus 2/3. So what is a common denominator that I can use for this, Tommy? 6. So 6, besides being just the least common denominator, it's also, if I would do 2 times 3, I'd get 6 also. So that one's not too bad. So I'm changing this 2 to a 6. What did I multiply by to get a 6? I multiplied by 3. Now, I don't really care so much that you're showing me the times 3. I'm going to write it up here on the board just because I want everyone to see like what I'm thinking completely. I don't want to do all mental steps on the board. But I do want to see when you're showing your work that you're changing your 2 to a 6. That means that I need to, step 2, change the numerator. So I'm going to change this. I'm going to do 1 times 3, which is 3. So I'm changing it to a 3/6. Now over here, I'm going to also change the denominator to a 6. That would be multiplying by 2. So that means I want to multiply my numerator also by 2, which would give me 4. Now, it is going to be your preference completely. Some of you might like to write it out. Some of you might even like to write it kind of like vertically. Some of you like write it like that. Do you like that better? If you like that better, then you can do that. Like, I am not saying you can't. I don't have your paper set up that way, like your assignment, but that doesn't mean you can't do it that way. That gives you a little bit more space. I'm one of those people that I just like cramming it all in there, and I have pretty neat handwriting, and I always have, so it was never an issue. If you're someone that you know you don't have very neat handwriting, then maybe you want to write it like that so you have some more space. Okay? All right, so let's go ahead and add just like we did yesterday. So my numerator is going to be in my answer 3 plus 4, 7, and my denominator is a 6. So I always need to check to see if I can simplify. That's going to be 1 and 1/6. All right, so same process if we were subtracting. I don't think we really need to do one of those, do we? No. So let's go ahead and move on to the mixed number problems so that we can have some of those examples in our notes for the mixed numbers. Let's see. Move up. People can still see that, all right? Let's say that we have 7 2/3 minus 3 5/11. Now, just like yesterday, you have the option of changing these into improper fractions first and then doing all the steps, or you can leave them as they are, fix your denominators and do all that stuff, and do it like that. So I'm going to do it the way that the majority of the class wants. Raise your hand if you like the improper fractions. Okay? Raise your hand if you like the other way of just leaving them as mixed numbers. Oh man, we're about like half and half. All right. How about if this is like if the only one we do, I'll do it both ways. Would that work for everyone? Just have one example then, the way they want? Okay. So I'll do first the improper fraction way, and then I'll do it the other way. Okay? So if I were using improper fractions, the first thing that I would want to do is go ahead and change these to improper fractions. So 3 times 7 is 21, plus 2 is 23/3, minus, that'd be 33 plus 5 is 38/11. Okay? Now I'm going to think about my common denominator. What is a common denominator? 33. I'm going to change my denominators to 33. So I need to multiply this by 11. You see where this is like gets a little ew, right? We're not using calculators. I need to do 23 times 11. It's not like we can't do it. It's just time consuming. 253. So 253/33. And then let me do my other one real quick. So this is changing to 33. That means I'm multiplying by 3. So I need to do 38 times 3. Let's see, I'll do that up here. 4, 9, 114 over 33. Okay. And then this is subtraction. I don't want to forget that part. Okay, so now I need to subtract 253 minus 114. That would give me 139 over 33. Okay, now I need to change it back into a mixed number. So I really don't want to completely do that in my head. Let's see. 99 would be times 3. Can we do another one? We should be able to, right? Times 4. Let's see, that's 12, 13, 7. So 7/33. Do you see how I did that? I had 7 left over. My remainder was 7, and 33 was what I was dividing by, so it's 4 and 7 over 33. Whew. All right, there's my final answer. It's a lot of work that way, isn't it? Yeah. So let's see if the other method, even though you may not like the other method as much, let's see if the other method maybe would be easier. Now, I'm going to go ahead and forewarn. Well, no, we might be okay on this one, actually. All right, so I'm just going to rewrite my problem, I think. Let's see if the other way is easier. So again, my problem was, where did I lose my papers to? They fell back here. They're hiding. Okay, so we already know that our common denominator is going to be 33. So if this is changing to 33, that's multiplying by 11. So 2 times 11, that's going to be 22. So I have 7 and 22 over 33 minus, over here, this changes to 33, that's multiplying by 3. So that's going to change to a 15. So 3 and 15 over 33. 7 minus 3 is 4. And 22 minus 15 is 7. Same answer. A lot less work, right? So you may not love that way, but that way is going to save you tons of work. But it's still going to be your choice what you want to do, okay? If you don't feel comfortable with it, don't do it. Do it the other way. It's just going to take you a lot longer, okay? Now your assignment, I don't have too many problems on your assignment because I know that they're more time consuming. I think there's only 8 of them on there. There's 4 fractions and then 4 mixed numbers, okay? All right, I'll get that for you. Let me stop this.